Patrick opens a savings account on the 1st of January 2012. He makes an immediate payment of 2,000 into the account and therefore a monthly payment of 1.2 at the end of each month. The last payment is made on the 31st of December 2013. Interest is calculated at 8% per year compounded monthly. So in this case, we know that this person was putting away money, so they were depositing money. So if a person is depositing money, we know that we're going to be using the future value formula, which is going to say F equal to X into 1 plus I to the power of N minus 1 all divided by I, right? So to get X and to get I, it's always the easiest part, but the challenge always comes at getting our N. But let's see what happens in this one. Let's first draw our timeline, right? It's always easier to first draw our timeline. And in this case, I see that it's 2 years. So it's like from January 1st, 2012 to 31st December 2012, and then January to December 2013. So when it's just 2 years like this, you don't need to draw only one timeline. You can draw two for better visualization. So in this case, we have these 2 years like that. We're told that he makes an immediate payment of 2,000 into the account and thereafter a monthly payment of 1.2 at the end of each month. Right, so we have two amounts here. I want us to focus on the one that he pays at the end of each month first before we can talk about the immediate payment. So we know that at the 1st of 2012, this is 2012, right? So at the 1st of 2012, we have the 1st of January here. And let's say January ends here. This is 31st of January. And then we come and say this is 31st of December, right? So this is where the immediate payment happened. So this is where it happened. So I want us to ignore the immediate payment for now and focus on what the future value is concerned about. So the future value is concerned about the regular payments. In other words, the 1.2 payments at the end of each month, at the end of January, at the end of Feb, at the end of March. In other words, if you continue with this cycle, you are going to have 12 payments, right? So we know that in the first year, we are going to have 12 payments of 1.2s, right? And also in the second year, because we're also going to continue and pay at the 31st of January 2013. So we are also going to have 12 by 1.2. In this case, we know that the payments that we had, because remember, our N is not the number of months that we were paying. It's the number of payments. A lot of people always confuse the N from compound interest and say, oh, it's the number of months. No, in this case, we are counting the number of payments. So we have had 12 payments in the first year, and we've also had 12 payments in the second year. So in other words, our N should be 24. We got our N. Now, let us deal with the 1.2 first. We'll come back to the immediate payment. It's easier to solve this. We're just going to say F is going to be 1.2, and then we have 1 plus our interest is 8% per year compounded monthly. In other words, we're going to have 0.08 divided by 12 all to the power of 20 minus 1. And we take that I and place it here. So 0.08 divided by 12. The answer that you get here is 30. I would like us to not round off now. 82771. You don't want to round off before we get to the final answer. So we know that if this person was paying 1.2 at the end of each month with that certain interest for 24 payments, not 24 months, this person is going to be having this certain amount. But we were told that this person made an immediate deposit. An immediate deposit is easy because it only happened once. So this 2000 happened here and it went for 2 years. So we didn't see any 2000s, right? So we only saw one 2000, and the following months, at the end of that very same month, we saw this person paying 1.2 at the end of each month consecutively. But we didn't see any 2000s anymore. So in other words, we can treat 2000 as just a compound interest. So in other words, we can use A equal to P1 plus I all to the power of N. And we know that our P is 2000 because it only happened once. There's no need to use the future value formula because the future value accounts for regular payments. And the 2000, it only occurred once in our timeline. So that's 2000, and then 1 plus 0.08 divided by 12. And it also went for 24 months. And then you get your answer as 2345.775 dot dot dot. I see that this is a bit longer. You don't need to round off here, just as I discussed in the other answer. So what you're going to do is you're going to take this number as is and you're going to add it to the future value that you got. You are going to take this and add it to this right here. So what I get is this person is going to get 33,465.60 at the end of these 2 years. 4.1.2 says Patrick decides not to withdraw the money on 31st of December 2013. He makes no further payments and the investment ends the same interest rate. Calculate the value of the investment on 31st May 2014, right? So this is still the easiest thing that you can get. Let me erase this real quick. So our answer was 33,465.60. So we are told that this person left this money in the bank and didn't continue to deposit any 1.2s or any 2000s. So if this person did not continue to deposit anything, it means we no longer treat it as a future value scenario. So now we just treat it as a compound interest scenario. So in other words, we're going to say A equal to P 1 plus I, and it's the same interest, luckily, right? So we know we have our P, we have our I. Now let's try to work our N now. So our N, we are told that it's at the 31st of December. So in other words, we're counting January, Feb, March, April, and then at the end of May. So that should be 5 months, like that, right? So we know that our N should be 5 months. So now let's try to solve this. We have 33,465.60. Then that's 1 plus 0.08 divided by 12, but it goes for 5 months, right? And then you punch this and see what you get. All right, so we get that he is going to be having 34,596.09 at the end of 31st May, right? Now let's continue to 4.2. 4.2 says Lily takes out a loan to the value of 150,000, right? So if they talk about the loan, we know we're going to talk about present value. So what is the formula of present value? The formula of present value is x, then 1 minus 1 plus I to the power of negative n, and then divided by I. So every time they talk about loans, usually I think in grade 12, they talk about loans for present values. So Lily takes out a loan to the value of 150,000. She repays the loan by means of equal payments, equal monthly installments, with which she makes at the end of each month. The first installment is made 3 months after the granting of the loan. So this is a deferred payment. So we know that we are dealing with a deferred payment situation, right? So we need to draw a timeline in this case. So it's made 3 months after the granting of the loan, and the last installment is 8 years after the granting of the loan, right? So in this case, we are given a temporary N, but we know that our N is not the number of months or the number of years that we have, not in grade 12, in grade 12 financial mathematics. In grade 12 financial mathematics, we use our N as our number of payments, right? So when they talk about 8 years and this person pays monthly, we know that we have a temporary N, which we can use to find our real N, right? So the loan last installment 8 years of the granting of the loan, the interest rate. So now let's find our N, because we know we can easily get our X and maybe our I. And yeah, but let's first deal with our N. So we know that our temporary N for now is 8 years, and this person pays monthly, so that's 8 by 12. which equals to 96. So our temporary N, remember, we're not going to use this. I mean, we may not use this, right? Because it may be different to the number of payments that this person paid. So we may not use this. So now let's deal with the issue of this person deferring. Okay, we were not given the exact date, but let's create our own timeline like this. Let's say this person took the loan on the 1st of January again. So this is 1-1, and then this is 3-1-1, right? And then this is going to be 2-8-2. Remember, at 3-1-1 at the end of January, that's also where February starts. Here you're going to have 31-3 like that, and you know that this is going to be April, but I don't want to continue that because we were told that this person deferred only for 3 months. If we took the loan on January like this, let's say 150k here, and we deferred the payment only to pay on the 3rd month. So in other words, we skipped the 1st, we skipped the 2nd, by the 3rd we paid. Now this is where a lot of students make a lot of mistakes, saying, oh, this person deferred for 3 months. No, this person missed the 1st, missed the 2nd, but on the 3rd month, although it's at the end, this person started paying. In other words, the 3rd month, we do not count it in our deferment. So this person only deferred for 2 months. Do you understand? We were told that this person paid 3 months after the loan was granted. You know that this person deferred for 2 months because 2 months was not paid. But as soon as the 3rd month was beginning to end or was ending, this person now paid the loan, started paying the loan. So in other words, the 3rd month was not deferred, but the first 2 months were deferred, right? So in other words, our loan now is no longer worth 150k. It now grew by a certain interest. It doesn't make sense to say, okay, I took 150k and I just let it without paying, and then I tell myself, oh, I'm still going to be paying the same 150k. No, it doesn't make sense. In other words, this person needs to incur the charges for the 2 months that he missed, right? So to incur the charges, you just use a simple compound interest. We know that this person is now going to pay 150k plus interest for 2 months, right? So we need to show this, that this person is going to pay 150k plus the interest for 2 months in our formula. So in other words, the payments that this person is going to pay, let's call this N-2. The real payments, remember our temporary or our theoretical N was 96, but now we saw that this person is not going to make 96 payments. This person is going to make 96 payments minus 2 payments that were deferred. So in other words, our real N now becomes what? Becomes 94, like that. So we have our real N, which is 94, and we have our N of interest. This is the N that this person is going to incur interest for 2 months because they deferred. So now let's plug this into our formula and see how it looks like. I am going to erase this plan. Right, now our formula is like this. Let's first write this side before I can write that side. So let me create some space. So let's say equal sign. We know that this side we will write something like 150k plus I, but I want us to write it in a mathematical way, nice financial mathematical way. So here we're going to have x because we are solving, calculate the value of the equal monthly installments. So we are solving for x in this case. So that's x being equal to 1 minus 1 plus the interest was 15% compounded monthly. So that's 0.15 divided by 12. We found our real N to be 94. So this is going to be negative 94. And then divide this by I. So here there's I. Divide this by I, which is 0.15 divided by 12. Right. So here we said this person is going to pay 150k plus certain interest. But this is not financial mathematics, right? So how do we write this to show that this person is going to have 150K combined with the interest for 2 months? So we use compound interest. We're going to have 150. Just know that we have 150K. Don't write 150K in your exams. 150K, 1 plus, what is our interest? 0.15 divided by 12, but it has interest for 2 months, right? So this is what this person now owes. This person no longer owes 150K alone. Now this person owes 150K plus interest for 2 months, because this is the interest for 2 months. This is actually the interest for 2 months. So 150K, also the interest for 2 months, right? So now we can solve for x. So in solving for x, in this case, I love to cross multiply. I don't know if you've been following me in this channel, but I love to cross multiply. In this case, what I am going to do is you can solve this in any way that you like. This is just a preference thing, right? So you can solve this in any way that you like. And according to my experience, they don't really mark you on how you use or how you multiply or how you solve for x. They just want to see you plugging in your formulas and then your final answers and then stuff like that. But how you cross multiply to get your final answer, I've never seen marks there, but it may be different. So if I'm wrong, you can multiply the way your teacher taught you or however you think is appropriate. So here's what I'm going to do, and I hope if you like it, I hope it makes sense to you. So what I need now is I want to be left with x. And I see that x has all these neighbors. It has this neighbor, all this 1 minus to the 1 to the whatever to the power negative 94, and also this division 0.15 divided by 12. So what I am going to do is I'm going to cancel all this stuff using a reciprocal of all this stuff. Now, what is a reciprocal? A reciprocal is given, let's say you have x divided by y. Reciprocal of x divided by y is y divided by x. In other words, we are going to multiply everything by its reciprocal. In other words, this is going to come here and this is going to come here. So when you multiply something by a reciprocal like this, right, you're also going to multiply with the reciprocal on the left hand side. So in other words, on the left hand side, we're going to have 150K, 1 plus 0.15 divided by 12 squared. This interest now comes and multiply the top side. So we're just going to say dot 0.15 to show that this we will multiply it now. And then we're going to say divide by, because this part, you see this large part of 1 minus 1 plus 0. Whatever, it's going to go at the bottom, because you see what we did with this reciprocal. It's going to go at the bottom. So we're going to say 1 minus 1 plus 0.15 divided by 12 to the power 94, negative 94 rather. And then here we'll only be left with x, because this will cancel with that and this will cancel with the interest. So x is now left alone. Right, so you can now easily punch this in your calculator. I found that x should be 2790.10 per month. Right, so this person should be paying 2790.10 per month. If this doesn't make sense, please shout out in the comments. I'll try maybe to explain. And if the method was a bit weird, by all means, use your own method. So I just love this. It makes things easier. And the more you practice it, the more you see that you don't need to think about reciprocity and everything else. You just need to say, oh, cross multiplication, and everything inverts. So it's easier as you go on. Now let me erase this so we can finalize this question. So we can go to 4.2.2. All right, 4.2.2 says, convert the interest rate to an effective interest rate rounded to 2 decimal places. These are the easy marks that you should not miss, right? So we are told to convert interest rate to an effective interest rate. So how do we get the effective interest rate? So we just say 1 plus I effective equals 1 plus I to the power of n to the power, divided by n all to the power of n. So in other words, to get the effective rate, we need to change the nominal rate. In other words, so I am just going to continue writing I instead of writing EF. Just know that this I is EF, right? So I is going to say 1 plus, what is I to the power of n? We put the interest that we were given, which is 15%. So in other words, we're going to say 0.15 here, and we're going to divide this by 12 because it was monthly. That's why it's a nominal interest rate. So, and we're also going to put our monthly there, and we're going to say -1. So to make this fun, or to make this quick, because this interest is going to be a percentage, you're just going to multiply this by 100, and then let's see what you get. So currently I get 16.08%. Right, so that is our effective interest rate. We've come to the end of question 4. I hope this session was fruitful for you and you've learned something new today. I hope you learned my methods of how to cross multiply using reciprocity. I hope that was very helpful. With that said, we are ending this question here. If you'd like to see more of this content from me, because you subscribing and liking gives me all the ego boost and all the confidence that I need. So just go down there and try to subscribe and try to like the video. It doesn't cost a thing. It's free. I know people like free stuff. So subscribing and liking the video is actually free. No strings attached. So just hit the like button, subscribe, and then you'll see that I will post more videos that will help you in the future. And make sure to share this video with other people who you think they're going to be helped. And remember to keep education fashionable always. See you in the next video.